friends, today we will cover the topic P-type semiconductor. Now in previous lecture we covered what is mean by semiconductor. Yes, what are the different classification of material, that is nothing but conductor, insulator and semiconductor, and then the types of the semiconductor. So as intrinsic semiconductor is nothing but the material which is available in its pure form, and the extrinsic semiconductor is nothing but we have to add the impurity. Okay, the material which is not available in its pure, or we can say extrinsic means impure form. Okay, so in order to add the impurities, that is called as the doping, we have the two methods. One is the donor impurity, another one is the acceptor impurity. Okay, so in order to construct the p-type semiconductor, we will use the acceptor impurity, or that is also called as the trivalent impurity. So this already I explained. Intrinsic means it is in pure form, extrinsic means it is in impure form. So in order to construct the p-type semiconductor, we use the acceptor impurity. So when the dopant of trivalent atom, that is nothing but the atom which consists of the 3 valence electron, okay, then it is called as the acceptor impurity. 3 valence electron, then it is called as the acceptor impurity, and the doping is called acceptor doping. So that is used to build this p-type semiconductor. So the example of the trivalent or acceptor impurities, we can say it is, we can use the boron, okay, then we can use the gallium, we can use the arsenide and indium. So these materials we can use to make this p-type semiconductor. Now how this p-type semiconductor it should get constructed? So the p-type semiconductor are formed by doping a pure germanium or silicon material crystal with the trivalent impurity. Okay, consider the boron. So see, this is the structure of silicon which consists of the 4 valence electron. Okay, then this silicon material we are get added with the another material, that is nothing but the boron. This is called as the trivalent. Okay, so this boron, if we consider the boron structure, it consists of only the 3 valence electron. Okay, so what we are going, we are adding the boron to the pure silicon crystal. Okay, so now what will happen? So the p-type semiconductor, basically it is formed by doping a silicon crystal with the trivalent impurities atom. So when atom is added to the silicon base, its 3 valence electron will form the covalent bond with the valence electron of 3 neighboring silicon atoms. Okay, so see, this is my boron which having the 3 valence electron, it should be get combined with the another 3 valence electron of neighboring silicon crystal. Now the fourth covalent bond, however, remains incomplete. It cannot make a pair. It incomplete, as this boron it has only the 3 valence electron. Now because of this incomplete, the resulting vacancy we can call it as hole. Okay, this we can call it as hole, and basically this hole, it is a positively charged, as it represents the absence of the negative charge. Thus, corresponding to each trivalent impurity atom, a hole is created. this increase the number of holes will make the semiconductor P type semiconductor material. So the P-type semiconductor material, the majority charge carrier R is nothing but the holes. And how this hole is created? As this boron, it has a trivalent impurity. This is silicon, it has a 4 valence electron. So this boron, it makes the band with the another silicon atom. So because of this is the 3 valence electron present, one it makes create a hole. And in this p-type semiconductor, the majority charge carrier, or we can say the current placed due to the only because of these holes. A p a p-type a p-type semiconductor, it is an intrinsic semiconductor doped with boron or indium. Silicon group of 4 has a 4 valence electron and boron of group 3 has a 3 valence electron. If a small amount of boron is doped to a single crystal of silicon, valence electron will be insufficient at one position to bond silicon and boron, so resulting in holes that lack electrons. When a voltage is applied in this state, the neighboring electrons move to the hole, so that the place where an electron was present becomes a new hole, and the hole appears to move the electrode in sequence. So what we can say, basically a p-type semiconductor, it is an intrinsic semiconductor and doped with which impurity? Boron or indium. The majority of carriers in a p-type semiconductor are holes. Electrons are minority carriers. In a p-type semiconductor, the hole density is much greater than electron density. And in an n-type semiconductor, intrinsic semiconductor, doped with the phosphorus and antimony as impurity, which we'll cover in the next video. Thank you.